What's up, everybody? I know it's a few seconds before I actually get started. I don't have the ding, but I see the record button and we're going. Good morning, good evening, good afternoon, good night, whatever time of day it is that you are watching this video today. We are going to cover notes over combining like terms. Easy day for us. I'm going to go through several of these examples with you. I'll let you know what they are. And then, of course, part of your assignment is to do and complete the examples that we don't do. Don't worry, I'm going to do half. I'm literally going to do half of the examples in the notes. The other half are up to you. Will they be a little bit more challenging? Yes, but I am certainly confident that with these notes, you can get them done. Notice that the other part to this e-learning assignment is for you to go on to complete homework 7, combining like terms. Only do the odd problems, though. There's 1 through 20 on that worksheet. I only want you to do the odd problems. So 1, 3, 5, 7, 9, all on up to 19. Make sense? So watch this video, complete the notes, do the examples that I don't do, and then just go on to do the odd problems. This should be enough for you today, and really, please get them done. I know you guys are rock stars, keep it on, right? And without further ado, we're just going to jump into this. There's an important thing in algebra, combining like terms, and really it's thinking about the terms that have something in common. So in this case, parts of an expression, we're going to break them up. So I see 7x plus 3 minus 5x plus 8 plus 4x minus 1. Right? We're going to have to add that on. We're going to have to simplify it. So what do we look at first? Well, let's look at variable terms. Obviously, these are terms with a variable. So what terms have those? Well, 7 has an x, so 7x is a variable term. What else? As I look over, there's negative 5x. And then 4x, right? Even more, we can narrow this down by asking, what are the coefficients? These are the numbers next to a variable. Simple enough. Numbers next to the variable, 7, that's right here. All right, then we've got a negative 5, and we've got 4. These are the coefficients, just the numbers that tell us how much of a variable we have, right? 7x, negative 5, 4x, 7, negative 5, 4. Then there's the constant terms. The constant terms are just terms without a variable. They never change. So, terms without a variable, well, we look up here. Well, I see 3. 3 doesn't have a variable. Let's see. 8 doesn't have a variable. And neither does this minus 1. So we'll call it a negative 1. Right? Now, we can simplify an algebraic expression by combining the like terms, the terms that have something in common, whether it's a variable term or constant term. Like I said. So we're going to combine those, and for every variable term that we have, I'm going to put one line under it. So 7x, negative 5x, and 4x, let's add those together. 7x minus 5x, well, that's just 2x. Notice that the only thing that changes is the coefficient out front. It's how many? It's like we have 7 x's, and we're taking away 5. So now we're left with 2. But then we've got a plus 4. 2 plus 4, 6. So we know that we're going to have 6x. And let's count the coefficients. I'm going to put double lines under these to know what's similar. So 1, 2 is the 3. 8 is a constant, and as is the minus 1. So 3 plus 8, 11. Take away 1, 10. It's a positive 10, so that means we're going to be adding 10. How cool is that? 6x plus 10 is our answer. So, got to kind of getting an idea so far, right? Well, we're going to do these examples. I'm going to do examples 1 through 4 with you. 5 through 8, something you will do. So let's start with this. Variable terms. What variable terms do we have? We have 3x plus 6x. That's really easy. That's just 9x, right? Then over here we have 9a minus 10a. Ooh, the only difference here is that we're not adding, we're subtracting. And we're subtracting the greater number. So 9 minus 10a, negative 1a. Or we can also write it as something else. Whenever we have a variable, and this is important, whenever we have a variable out front, and there's a 1, that 1 basically becomes invisible. We just say that 1 times a is a, right? So we can write that as just a. Now, it will still be negative, but I can write it without the 1 because we already have the number itself. So minus a. Right here, we're going to start adding in some numbers. And as we get farther along, I know you'll be able to do 5 through 8. I do. It's not that hard. We're doing that same process where all we're going to do is we're going to say, hey, variable, here's a variable. This is just a constant. Let's add the variables together. Simplify it. 7m minus 5m. Well, 7 minus 5, that's just 2. I have 2 m's left, and I'm taking away 6. I apologize for the bell. I forgot the bell was there. Right, then we're going to do number 4. Number 4 says 9 minus 6w plus 5. Well, what do you notice about the variables? There's only 1. There's only 1. So we're going to focus on the constants first. 2 for the constants. I'm going to bring down the negative 6w. 9 plus 5 is 14. So there's 2 ways you could have written this. If you wanted to write 14 minus 6w, that works. If you want to keep it like negative 6w plus 14, you can do that. Keep on with those lines. Do 1 line for the variables, 2 lines for the constants, and then add them together and see what you get. You guys can do this. I know you got 5 through 8, so go ahead. And then we're going to keep on keeping on. Like I said, it's like just keep swimming, right? Now, what happens when we have exponents? We want to combine like terms with the same exponents. So terms with the same exponents, or combination of variables and exponents, are considered like terms, right? So when combined, be sure not to change the exponents. That's a thing. The exponents don't change. They stay the same. So for example, I have 5x squared plus 7x squared. The x squared is the variable. It's a variable with an exponent, but it still remains x squared, right? Then all we do is just add the coefficients together. So then 5 plus 7, 12. 12x squared. We're going to see the same thing as we continue on. Terms with the same exponent, you group together. You just don't change the exponent. So negative 15n to the 5th plus 4n to the 5th. It's still n to the 5th. That n to the 5th doesn't change. And that is kind of a weird 5, isn't it? But it's still a 5. So then what's negative 15 plus 4? Well, hopefully you're thinking to yourself, well, normally 11 minus 4 would be 11. But this is clearly going to be negative because of the 15. So negative 11 n to the 5th. All right, let's see what we have next. We have one that's a little bit different. We've got 3. I've got a c to the 3rd, c to the 3rd, c to the 3rd. Notice that all of these exponents are still the same. So it's always c to the 3rd. 8 minus 7, that's just 1, plus 16 makes 17. 17c cubed. All right, as we move on to 12, and I'll do number 13 here for you, just so we hammer in the idea. I've got a mix now of k squareds and k's. Now make sure you don't add those together because they're still different. K squared is different from k. So for the k squareds, I'm going to do 3 lines now. So I see a k squared, I'm going to do 3 lines. For a k, I'm just going to do 2. So there's minus k, there's minus 5k. Then I've got a constant, which is 7. And then I've got another k squared. I only combine those with k squareds. Then I work down to those that have just k. And then, last but not least, just the constants. So let's start with the k squareds. The 2k squareds are 8k squared and negative 2k squared. So I know I'm going to have k squared. 8 minus 2, 6. Easy enough. Then we're going to do something with the k's. Now notice that they're both minus. That means I'm going to have a negative. And I'm going to subtract. So I know I'm subtracting something k. And just like I said, there's no number out front here of this k. So that means it's going to be negative 1k. So minus 1 minus 5, it's negative 6. So minus 6k. And then all we have left for constants is just 7. So then, 6k squared minus 6k plus 7. I know that pen is in an interesting place, isn't it? Make sure that you're being careful not to combine exponents with non-exponents. That's one thing that we are going to be a little bit concerned about. Number 13, because I'll do it real quick. We need to be careful. In this case, notice that what we have is a squared b, a squared times b. That is our variable. If it was something else like a squared, b squared, and then this was a squared b, you wouldn't combine them because the exponents are not the same. Now in this case, the exponents are the same. So let's go ahead and combine these because I see a squared b, and I'm going to use the 2 lines for this one since we have just one constant. Negative 4 a squared b plus 10, that's 6. And then we just add the 7. 6a squared b plus 7. Fair enough, right? Remember, when you get down to here, x squared is different from xy, and it's different from y squared. Don't add those together. Same thing down here. A squared is not the same as ab. Don't get those together either. And then on with 16 as well. All right, so take a moment if you want to finish those, pause the video, and we're going to get right back to it. These are the last 4 examples in our notes, and I'll do the first 2. In a geometric application, geometry, we talk about shapes. We're not there yet, but we can still think about shapes and how to apply this algebraic technique of combining like terms. So, give it the perimeter of each figure as a simplified expression. This is nice, right? Because perimeter is so easy, isn't it? It's just all the sides around a shape added up. So all we have to do is take the sides and add them together. And if you want to skip the step of writing all of them down, you can do that. I'm going to do it for this first one here. So 2x plus 1 plus x plus 3x. This is the expression for the perimeter. It's all the sides added up. Now I want to combine the like terms and get something simplified. So I have 2x, I have an x, and I have a 3x. Then I have just a constant. All right, so 2x plus 1x, because that's what it is, that's 3, plus 3 is 6. So we have 6x. And then we just add in the constant. Where's the constant? It's just 1. So 6x plus 1. And that's all we're looking for. This is a simplified expression. And we're going to do the same thing for 18. But instead of rewriting my statement down here, I'm just going to underline what we have up here. Remember that all we're doing for perimeter is just adding up all the sides. So, as I look at this, let's look at the variables first. I have a minus 1a, and I have a 5a. Notice that up here, I have a 4ab. But that's not the same thing as just an a, is it? So we're not going to include that. For the constants, we can just use 2 lines. And I see that I have a 17, and I also have a negative 1. Then for this one up here, I'm going to use a 3 because that's different. All right? And we can write our expression by adding these up. Sure, let's start with the variables first. So I have a minus a and a 5a. And up here you're thinking 5 minus 1, that's 4. So we have 4a. Let's add up the constants next. I've got 17 and minus 1, that's 16. So 4a plus 16 so far. And then we're just going to add in that 4ab. All right? You're going to do the same thing with these. Remember, when it comes to a rectangle, the opposite sides are equal. So let me go ahead, just clarify. That means this side is 3y minus 5. And it means that this side, opposite from this side, is y plus 2. Right? Then you're just going to add all those up, and you're going to get your simplified expression here. As for 20, make sure you notice that there's k squareds and there's k's. Don't get the two mixed up. They are different. That's it for me in these notes. Hopefully that wasn't too long for you. I look forward to seeing your work in class or in Canvas, whichever one it is. If you have any questions, make sure you shoot those to me. Other than that, I hope you guys have a great day, have a great weekend. Whenever it is you're watching this, I will see you next time.